In today's tutorial, we'll be learning how Scipy is used for image manipulation and various activities that can be performed on image. Now for this, we'll be using scipy.ndimage, which provides manipulation of n-dimensional arrays as images. Now let us import the important libraries for that. First of all, let us import now from Scipy. It is import miscellaneous. This is used to load an image. We'll be using that, you'll come to know. And in the image, now this is the model that is very important, and various function, it carries out various functions for manipulation. After that, we'll be importing numpy as np. We need to plot all these images. So for that, we'll be calling matplotlib. Matplotlib. Okay. So from matplotlib, import pyplot and as plt. Now, Scipy, using scipy.ndimage is one of the method that can be used. Now, another method to use for image manipulation is OpenCV. Now, since we have imported all the necessary libraries, let us now see how can we do geometrical transformations on images. For that, as we just mentioned in miscellaneous, we can import or load an image, right? So let us do that. So let us name face. Okay, face is equal to miscellaneous dot face, and we'll be having the gray level image, right? So that is why we are keeping it as true. Now, after this, let us just plot it, right? So let us just do it as plt dot im show face, right? So here you go. This is the image that has come, but we need a gray level image. So what do? We just add here as cmap. We are mapping our image to cm. No, but for that we'll be using matplotlib criteria. So plt dot cm dot gray. All right. Now let us see the gray level image for the same. Okay. Okay, so this is cm. Now this is the gray level image that we'll be able to see. Now on this, we'll be using several different geometrical transformations. First of all, let us see that how can we shift the image. Now this is the image that you are able to see over here. What if I want to shift the image a little bit on right? So how can we do that? We can just do it as let's just call it as x is equal to, and we'll be using ndimage and dimensional image, and we first have to use this shift function. After that, we'll be giving our face as the input, and thereafter how much do we want to shift? So that is by 50 comma 50, and after that, similarly, let us call this, and here we'll write x. Now you should see the difference. This is the image previously that we got, and this is the shifted image that we got. Now what if I don't want these black edges that you are able to see over here? So for the same, we'll copy this and make the changes here itself. Let us call this as y, and we'll be shifting here, but the only thing that we'll be changing here is that we'll be doing mod is equal to nearest. Okay, and here we'll have y. Now, if you can see, the black portion that was coming over here is now it's taking the nearest mode, and which is why this is coming as a blurred, liney structure of the image. Let us just see the documentation of shift, and here you go. Now it takes these as the input. We have kept, if let us see, if we keep mode as constant. So I guess you can think of the output that we can get. Yep, so this is the same output that you have got, and if we keep nearest, then it takes the nearest values and manipulates the pixels that way. So this is how it looks like. So there are different kind of modes: reflect, constant, nearest, mirror, wrap. So what if we use reflect, for instance? Then this is the image that you'll see. All the boundary values that we're having, they are reflected back. Similarly, you can even try out for other values over here. And they are showing that how are these reflected pixels working, how are constant pixels working. So K means black. How are the grid constant of pixels working? How are the nearest working? So if my ABCD is my pixels, then the nearest to this nearest in this area is the A pixel, and nearest here is the D pixel. That is why they're just copying it. And this is how mirror pixel works. This is how grid wrap pixel works. It is a very interesting output to see. So let us just say it as grid wrap. Yeah. So this is how it is working. So this is what grid wrap is. It's the same thing, and we are wrapping up. And the CY value pre-filters, it returns the ND array. So this image is actually the array of pixels that we have. So because this is grayscale image, this is a two-dimensional image which has white or black, and pixels range into that value. For RGB, it is three-dimensional array, which is R red, G green, and B blue, right? So this is all the documentation for shift. Now let us move ahead with some different kind of functionality. Let us try to rotate our image. Let us call this as Z, and instead of shift, we'll write rotate. Now we want to rotate our image that has been given to us. How much do we want to rotate? Let us say 30-degree, right? And here we'll give Z, and let's see the output that is coming. So this is how our image is rotating. What if I do it as 90? You can think of the output that came. Yes, so it has rotated. It goes anti-clockwise, right? And this is the documentation for the same, which you can see. So we are taking these as the input. If we want to reshape or not, for by default it is true. So we are having the axis. On what axis do we want to rotate? Thereafter reshape, output, order, mode. Here in the mode also, what see, for example, if I rotate it by 30, and if I keep mode is equal to wrap. So you can think of the output that will come. So it is wrapping up the other parts of the image with the same values. So this is how wrap works, right? And it returns the ND array. And similarly, they have given an example for the same. So this is how a rotate works. Now, what if I want to crop a portion? So for that, how we do it, let us name it as A, right? And we'll not this thing, not need this thing. So we'll just use no function for the same. It's just cropping. How do we crop a normal array? This is the same way that we'll be cropping, right? So for cropping, we use the slicing operator. So as I told you, image is nothing but array of pixels. It is a matrix or grid of pixels. In the same way, we'll be cropping it. So I'll be taking the first 50 rows and columns in the very first matrix, and similarly for the second matrix, right? So 52 minus 50. and we'll be plotting our A over here. Okay, so here we have an error and this is not the syntax. Let me just change it. And here you go. This should work. Yes. So this is how a cropped image will look like. What if I will keep it as -5? So this is how it will look. It has expanded this side, right? So this is how we can do cropping. It's a very normal array operation that we can do. Cropping is what we are cropping that part of image. What if we want to zoom the image? Thereafter, how do we do that? Let me just paste this again, then call it as B, and we'll write nd dot zoom, right? And for that, let me zoom up to 2. And let us print the result, and meanwhile even see that what the documentation for the same is. Here you go. So this is the output of the zoomed image that you are getting. So the 2 is the zoom ratio that we are getting. So float or sequence, the zoom factor along the axis. It is a float. Zoom is the same for each axis, right? And after that we have order. We even have mode over here, C value, grid boolean value, and all. And it returns the zoomed ND array. What if I want to zoom up to 5? It is taking a while. Yes. Another hack that I would like to tell you all, what if you don't wish to see this as the output, you just have to add a semicolon over here and directly the image will come. The unwanted output won't be visible. So let us see how it is happening. So since we have increased the zoom factor, it is taking this much time. And this is how our output looks like. So this was all about geometrical transformation wherein we were changing the orientation, we were cropping, zooming, changing the resolution. Now we'll come down to the next part of image manipulation wherein we use image filtering. So there can be a very noisy phase wherein we smoothen the image, or we want to change the image to a grainy filter. There are a lot of trends in which there are grainy filter to make it as a retro look. So how do you do that? So for the same we have face, and let me write again, face is equal to, we are trying to crop out a part of the face. So let me write as image is equal to face and cropping out 512 and minus 512. Okay, and we want to have a noisy face. So let us have noisy. We have to add some noise to the matrix. So first of all, let us get the noise. So let noise is nothing but just random numbers that we just add to the array. So it is np.copy. We copy our image that we have taken to as type. We change the type over here to float values. Okay, and thereafter we do noisy is equal to noisy and plus image dot standard deviation. Okay, so here what we have taken the noisy face and we have added any standard deviation, and let us just continue this ahead and add more noise. So I'll be multiplying it with 0.5 and any random uh, numbers. So standard normal, and we have image dot shape, because if I want to assign back to noisy, it has to be of the same shape that it was earlier, and that is why we assign face dot shape. And yes, so let us try to go ahead and do some other operations too, maybe, or let us print this first. So we'll do plt dot im show, and it will be our noisy And for that, we have to take cmap is equal to plt dot cm dot gray. Now let us see what is the output that we are getting. Okay, so it is saying that it is having a invalid shape, and let us see. Okay, so there is one thing that we had to do over here. Yes. Yeah, so this is the noisy image which you are able to see over here. As you can see, there are very fine noise detailings over here, and we have cropped this part. So what if I just plot the uh, let me just copy this and let me just plot the cropped part so as for you to see the difference. See, this is the original cropped image, and this is the image which has noise over here. So that is the difference. Now, what if I have to blur the image? Now, once I have the noisy image, but I don't want the noise, I want to blur that out. So how do I do that? I just write blurry is equal to ndimage dot, we normally use the Gaussian filter over here. We'll pass our noisy image over here because I want to smoothen that image and the amount of noise that one will want. So let us write sigma is equal to what, 3 maybe. Yeah, let us go with that and try and print it. So yes. Now this is the blurred image. This was the actual image. This is how the noise was added, and to this noisy image we have blurred it. What if I increase the blurring point to more? This is blurred this much. So you can always play around with the numbers over here. Let me just keep it to 3 and move ahead. Now in the previous tutorial, I had explained that median is used a lot into image processing because it is very good for salt and pepper noise. So salt and pepper, what is that is black and white, and this image is also black and white. And to remove the noise from this, we use median filter. Median filter is a very robust filter that can be used so as to remove the salt and pepper noise. And on this image, let us see how it works. So median phase is equal to nd image dot, we'll write median filter. So yeah, here we have the median filter, and to this we'll add the blurry image, and after that let us keep the size is equal to 5 and we'll even plot it. So meanwhile we are plotting this, let us just see the documentation for a Gaussian filter. And we have the sigma value. Sigma value is the scalar of sequence of the scalars, and standard deviation for the Gaussian kernel. Thereafter, we have the order, output, mode. Mode is a common thing that stays, and the C value, truncate, and the Gaussian filter value is given as the output. Similarly, this is how the salt and pepper noise is removed, and we have applied the median filter. Let us see the documentation for the same. For this, your size is nothing but footprint is guys. It is a scalar or tuple value, and it is optional. It is okay if you don't want to give. And footprint below, so it is related to this, right? You can always have a look to the official documentation that has been given over here, and this is the example that they have given. So this is how it works. Another kind of filter that can be used is a Wiener filter, and for that signal is used. Scipy.signal is also one of the module which can be used to work on with different signal type of data, right? So after this, there is another topic for which we can use image manipulation is using mathematical morphology. So this basically involves using erosion, dilation, closing, and opening. Erosion is nothing but shrinking the image, and dilation is nothing but increasing the size of image. So that can be easily done using ndimage.binary erosion and binary dilation. So I'll just show you one of the examples. Now, what if I have az equal to np dot a whole zeros matrix? Let me take it as a 7x7 matrix, right? And let us keep the type of the values as integer. Okay, and to these values, it is all zero values. Into these we'll add some ones because you want to see that how the image is expanding. So to these we'll add ones and let us print how our A looks. So this is how our A matrix looks, and these are some of the ones that you are seeing over here. Now I want to perform erosion on this. So how do I do that? I'll just do in the image dot erosion, right? So it is not directly erosion, it is binary erosion, and to this we'll be doing erosion on A, and we'll be doing as type A dot T type. So erosion has to be done on what type of values? Integer type of values, and this is how the output we are getting. So our image has been shrunk only to this much, and let us see the documentation for the same, that how is this working. So binary erosion is a mathematical morphology operation used for image processing, and it is given with a structuring element. We give the input array, the structure array like iterations, that is also optional. Mask, what should be the mask that should go on this, and thereafter the border value and everything. So for the mask, if the mask is given, only those elements with true value at the corresponding mask are modified at each iteration. This is how erosion works. Now, what if I want to perform dilation on the same image and binary dilation? See, this was the image. Now it has increased. The border values numbers are increasing on it. And that is how our dilation is being performed. Now, after that, we have a concept called closing and another concept called opening. So closing is nothing but closing is dilation uh, performed and thereafter erosion is performed, and for opening it is erosion performed and thereafter dilation. So this is what closing and opening means, and for that you already have the values for the same. So this is how image manipulation takes place using Scipy ndimage. There are several different functions that you can see wherein we are applying mask to the image. Mask is nothing like you applying mask to your face, the same way you apply mask to an image and thereafter you perform some operations. So all of that is under ndimage, and you can always go through their official documents so as to learn the different functionalities that are performed. That was all. Thank you.